everybody! Welcome to another episode of Show About Science. This is your host, Nate. Black holes are very cool to learn about, but make sure to study them from a safe distance. I'm starting to feel the gravitational pull of some awesome questions, so let's get this interview started and meet our guest, Bob. Hi, Bob. Welcome to the show.
Hey, Nate. Thank you for having me.
Can you tell our listeners a little bit about yourself?
Sure. So my name is Bob McNees, and I'm a physicist. I don't know if you've had any physicists on your show before, but a physicist is a kind of scientist who is interested in really basic questions about how nature works.
I think I've had one or two.
One or two?
Yeah, one or two physicists.
Mm-hmm.
So, let me get this straight. Do you, work on quantum mechanics, space, those things, and,
Yeah.
water? So, everything from water ripples to the ripples of a black hole?
That's right. So one of the things that I'm really curious about is how gravity works when it gets really, really strong, and also how gravity works when you have to think about quantum mechanics, too. And that's something kind of unusual. It's something that we don't see here on Earth very much, but it's important for understanding how black holes behave and kind of how the universe behaves too.
So could you explain what black holes are and how they work?
Oh, I can try. So a black hole is a place in space where gravity has become so strong that nothing can leave that place. So things can go in there, but they can't come back out. Sometimes people talk about it like it's a giant vacuum cleaner that sucks things in, but it's not really like that. Outside a black hole, gravity works just the same way it does outside a star or a planet. It's just really stronger when you get really close to it. So for a long time, scientists thought about gravity as a way that things pull on each other. A scientist named Isaac Newton described gravity that way. And that makes a lot of sense because, we think about the Earth pulls on you and me and on the moon and things like that. So that's a really good way to think about gravity most of the time. But then about 100 years ago, another scientist named Albert Einstein kind of gave us a different way of thinking about gravity as a way of explaining kind of how big objects like stars and planets affect the way that we can move around them. And usually this works out the same way as our other way of thinking about gravity, things pulling on each other. But sometimes when gravity gets really, really strong, it works a little differently. So after Einstein introduced his way of thinking about gravity, people realized that sometimes gravity can become so strong that you can have a place where things can only move in ways that never let them leave. So when something kind of goes inside a black hole, the rules for how it can move because of gravity means that it has to stay in there, and actually it eventually kind of has to go into the center of a black hole. So everything that goes in kind of has to keep going in.
Okay, so is there an end to a black hole?
Well, that's a really great question. So for a long time, scientists thought that black holes could just get bigger and bigger and bigger. As more things fall in, they get bigger. It's kind of like when you eat a big dinner and you feel bigger afterwards, except it just keeps going. So as black holes eat things, as gas falls in and dust and stars and things, they get bigger and bigger. So for a long time, scientists thought that black holes could only get bigger. But then in the 1970s, about 40 years ago, a scientist named Stephen Hawking said, if you wait a really, really, really long time, I mean a really long time, black holes can actually kind of go poof and disappear. It takes a long time. But he studied black holes and what happens to black holes when you think about quantum mechanics too, and he discovered that they eventually go away.
So we answered if they can die, but where do they end? Where does stuff have to stop when they go through it?
I see. So if somebody falls into a black hole, where does it end?
Yes.
Oh, okay. That's a really good question. So when something goes into a black hole, once it goes inside, it kind of has to keep going toward the center. And it doesn't probably take a very long time. But everything that goes into a black hole has to go towards the center. And the closer you get to the center, the stronger gravity is, and the more stuff is kind of smushed down in there. So gravity gets really, really strong. And we don't exactly know what happens in the middle. So, we study nature and we look at how things work and we look at planets and galaxies. And from there, we have a really good idea of how gravity describes the things we see. But we don't know exactly what happens in a black hole. Gravity is so strong there that we kind of have to say, I don't know if our rules for gravity are going to make much sense anymore. It could work totally differently than we understand. So if something falls into a really big black hole, kind of like the black hole at the center of our galaxy, and it doesn't try to stay out, you don't try to use a rocket or something to keep it from falling in. The thing just falls into the black hole, and at first it doesn't feel anything. It's not like when you're in your car and you hit a speed bump and the whole car shakes. The only thing it notices is because of the really strong gravity, light moves in funny ways. And so, you see lots of strange things, but you don't really feel anything. But once something falls a little deeper into the black hole, once it's gone in and gone a little ways, things start to get really weird. Do you like spaghetti, Nate?
Yes.
I'm glad to hear that, because when things get too deep into the black hole, as they get close to the center, something called spaghettification happens.
Oh yeah, spaghettification. Isn't that where two black holes collide and it sends ripples throughout the galaxy and everything in the path of the ripples gets turned into waves?
That's something a little different. That's gravitational waves. But if something falls into a black hole, once it's kind of getting closer to the center, something funny happens. So here on Earth, you don't really notice this, but gravity is a little stronger down at your feet than it is up at your head. Now, if something falls into a black hole, like if I jump feet first into a black hole, as I'm getting closer to the center, because gravity is so much stronger inside the black hole, then gravity is pulling a lot stronger on my feet than it is on my head. And because of this, I would get really stretched out. I would get stretched out like a piece of spaghetti, which I don't think I would like, but maybe if you really liked spaghetti, would be okay. So when things fall into a black hole, as they get deeper in, they get stretched out like spaghetti. And then after that, as they get even closer to the center, that's the part where we don't know exactly what happens. We know that things have to keep going towards the middle, but in the very middle, we don't know exactly what happens there.
Do you mind if I come up with a hypothesis on the spot?
I would love if you come up with a hypothesis on the spot.
So about that question, a thing falls in.
Okay.
They go in and then once they reach a certain point, they get burned to ashes.
They get burnt to ashes?
Yes, and then they go through this molten plasma.
Okay.
Then they go through the other end and they continue for an infinite distance, but we can't see that because the black hole bends light.
That's right.
And we think it's just flat. I know what you're thinking, but yeah, it's basically the warp hole theory.
Oh, the wormhole theory?
Yes, but it's a little bit different.
Okay.
And then splits into a different route, but you don't know which one you're choosing. And it goes into different galaxies or possibly even different universes.
I think that is a really cool sounding idea. There are lots of things that I hear in your hypothesis that are things that scientists spend a lot of time talking about. One of the first things you told me was you think when they go in, they get burnt up, did you say?
Burnt to ashes.
Burnt to ashes. So I told you that maybe 40 years ago, a scientist named Stephen Hawking said that he thought that if you waited long enough, a really long time, black holes should kind of go poof. He said black holes actually kind of have a temperature, and so they kind of sometimes emit things. And so that got people thinking, and they spent a lot of time trying to figure out what that means. And about 10 years ago, some scientists said that they thought that if you fall into a black hole, something like that should happen. You should see something that they called a firewall. And a firewall was a place where you go in a little ways, and it's very, very hot, and lots of things happening, and that anything that went through there would get burnt to ash, just like you say. Other scientists have kind of explored the idea of what you called a wormhole. That is that when you go into a black hole, something funny happens, and maybe it connects to another point in space. That is one of the most fun ideas to think about for me. And people have used that as a way to make all kinds of cool science fiction stories where you go into a black hole and come out somewhere far away that you've never seen before. So I think that hypothesis is full of all kinds of really interesting ideas. And there are lots of scientists who spend their time thinking about how they would work and what they would mean.
Is the universe a hologram?
Is the universe a hologram? That is another great question. And the answer is, I don't know. But there are some funny things about how gravity works when it gets really strong, some funny things about how black holes work that make us think that the rules for how we describe our universe work kind of like the way a hologram works. Do you know what a hologram is?
Yes.
Okay, so just in case your listeners don't know, do you want to describe it or do you want me to describe it?
Just in case I'm wrong, could you describe it? You probably know more than I do.
Sure. Well, who knows? I might get it wrong too. We'll have to fact check what I say. So a hologram is kind of a three-dimensional looking image that you make on a two-dimensional surface. You record lots of information on a flat surface, and then when you shine light on it, it looks three-dimensional to you. So it's flat, but it looks like it has depth to it, right? It's kind of a neat trick of light. So the rules for a black hole are kind of funny that way. They look like something you would expect for a flat surface, even though we're supposed to have like depth. We're supposed to have three dimensions. So even though space should have three dimensions, the rules for a black hole kind of look like the rules you would expect on a flat surface. And so that made people think, oh, it's kind of like a hologram. Like all this information that's in the black hole is there on the surface. Kind of like all the information about that image you see when you look at a hologram is just there on the surface. And so that made some other scientists think, well, maybe the whole universe works that way. And people have spent a lot of time exploring that idea. And it's still just kind of a hypothesis, right? It's an idea that people are trying to use to maybe help figure out how to make sense of gravity and quantum mechanics at the same time. It's kind of a clue.
Can you tell me about the information paradox?
The information paradox. I can try. So when something falls into a black hole, it's gone. As far as we understand it. We said that once you go into a black hole, there's no coming back out. So let's say you took a cup of coffee, right?
Yes.
And you're going to take it and you're going to drop it in the black hole. And then you say, well, wait a second. There was lots of stuff there in that cup of coffee. And now it's all gone. It's in the black hole. So does that mean it's gone forever? And for a long time, scientists thought, yeah, it's just gone forever. But then scientists who study quantum mechanics, right? Quantum mechanics, that's our ideas about how really small things work. Things like atoms and tiny subatomic particles. Scientists who study quantum mechanics said, we have to be careful about that because quantum mechanics says that you can't lose things forever. And so then no one was sure what to make of that because you have the ideas about black holes and they're saying, okay, well, if I drop my cup of coffee in the black hole, it's gone forever. And then you have your ideas about quantum mechanics and they say, in our universe, you can't lose things forever. That information about your cup of coffee, everything there was to know about all the little particles and atoms in it and how they were moving around, that information still has to be there somewhere. And so that's the information paradox because you have one really good idea that says, well, that information's gone forever. And then you have another really good idea that says all that information always has to be there. And they can't both be right. So you got to figure out a way to make sense of it. And some people said, well, our ideas about black holes are right. And the information that was in your cup of coffee just has to be gone forever. And you people doing quantum mechanics have to change your rules. And the people who do quantum mechanics said, no, 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 the rules for quantum mechanics are right. And you people doing black hole stuff, you have to change your rules because the information can't be lost forever. And so no one knows the exact answer. Most scientists think that the quantum mechanics rules are right, that the information is still there, and it's kind of hidden in the black hole somehow. But if you were really careful, you could figure it out. So that scientist I was telling you about, Stephen Hawking, he made a famous bet with some other scientists. he said, I think that any information about your cup of coffee that falls into the black hole is gone forever. And some other scientists said, no, I think it's the other way. And maybe 15 or 20 years ago, Stephen Hawking decided, I think the other scientists are right, and they win the bet.
Okay, so thank you for being on the show.
Thank you so much for having me. This was a lot of fun. Can I tell you that I really liked your hypothesis, and I hope you keep making lots of new hypotheses.
Oh, thanks.
And maybe if you think of some more good ones, maybe you could send them to me.
There you have it, folks. The show about science is complete. Music on this episode was produced by the mysterious Breakmaster Cylinder, and our theme music was written by Jeff, Dan, and Teresa Brooks. Okay, Dad, you can shut the recording off. For the newest episodes of the show about science, download the Pin app or go to pinna.fm/promo.